Welcome to qnawire.
Here we want to solve for time, acceleration, and initial velocity for the following equation. We're going to have x equal x0 plus b naught times t plus 1/2 of acceleration times square. So first of all, solving for acceleration is going to be one of the simplest ones. In this case, we're going to have x minus x0 minus b naught times t is going to be equal to 1/2 of acceleration times squared. So the value for acceleration is going to be equal to x minus x0 minus b0 times t multiplied by 2 divided by time squared. Next up, we're going to solve for b naught, our initial velocity. So in this case, we're going to have x minus x0 minus 1/2 of acceleration times squared is going to be equal to b0t. So the only thing that we need to do over here is b naught is going to be equal to x minus x0 minus 1/2 of acceleration times squared, and all of this divided by the value for time. Oops. Let me put this line a little bit more straight by t. And finally, we want to solve for t on the equation x equals x0 plus b naught t plus 1/2 of acceleration times squared. And in this case, I want you to notice that this is going to be a quadratic expression. If we do rearrange this as 1/2 of acceleration times squared plus b naught times t plus x0 minus x equal to 0, we're going to have a quadratic expression. So over here, we're going to have two possible values for time. Depending on the situation that you have, one of them is going to be a physical solution and the other one may not be. So in this case, t 1, 2 is going to be equal to the good old general formula, or as it is known in Mexico, la chicharronera. So in this case, this is going to be, let's identify all of the terms on our quadratic expression. This is going to be the first term a, b, and c. And remember that the general formula tells us that the solutions are going to be minus b plus minus square root of b squared minus 4 times ac, the discriminant, divided by 2 times a. So in this case, what we want to do is minus b naught plus minus a square root of b naught squared minus 4 times as a times c. In this case, a is going to be equal to 1/2 of a t squared times the value, 1/2 of a without the t squared, times the value for c. In this case, we're going to label this as minus a displacement because, as you notice, this is going to be initial position minus final position. So this is the same as putting minus the displacement of the movement. So minus d over here. Divided by 2 times a. In this case, it becomes directly the acceleration. Just a note for you to remember, x0 minus x is going to be equal to the value for minus d. Okay? So you can have positive or negative displacements. Rearranging this equation, t1, 2, is going to be equal to minus b naught plus minus square root b0 squared plus 4 and 2 are going to cancel out, and we're going to have 2 times a times distance divided by a. And this is going to be the solution for time that we're going to have. Remember that the value for d comes from solving this part of the equation. You can also replace it directly, and you can put in here, if you want, t12 equal to minus b naught plus minus the square root of b0 squared minus 2a times x0 minus x divided by a. So both of the approaches are valid. Whichever one you feel more comfortable with, that's the correct one. So that would be all. Thank you very much and have a good one.